Okay, this is a typical graphical solution question. So the whole question is about a graph. But this is the first time I think the graph is being split. So some of you might have issue with this graph. Okay, so before I explain this graph, I think we just go through the answering first. Okay, most of you will be okay to get this value. Show your working by putting x equal to 3 into the equation. Okay, now the drawing is the problematic part. So if you start to draw, you will find there's the graph will look weird. And in this case, the graph look weird because this is the first time, right? There's actually a denominator with x. If a graph comes with a denominator with x, there's actually some undefined values. That means there will be some values that is not calculatable. So the one that is not calculatable, right, is actually x equal to 0. So if you try putting x equal to 0, you can try on your calculator right now. You will find that your calculator gave you an error. So when your calculator give you an error, right, that means, right, this is something like what we call asymptote. But they are not expecting that you draw this asymptote. That means, right, this is a vertical line that the graph cannot get near. The graph cannot cut. It's like a restricted zone because the calculator actually gave you an undefined value. So because of this reason, you have a restricted zone. And because of the restricted zone, this one is actually the y-axis. Your graph actually turns out looking like this. So the restricted axis is here. It's like a restricted boundary. So you shouldn't be joining these 2 points. So some of you, right, when you plot, you will find why are my points like that and how am I supposed to join something like this? No, you are not supposed to join. So in this case, right, you will just have something like 2 separate portion of the graph. Okay, so 2 separate portion of the graph because the y-axis is a restricted zone. The correct term will be it is a vertical asymptote. So you do not need to know the correct term. You just need to know that it's a restricted zone. So the curve cannot cross over. It's like a boundary that the curve won't cross over. That's why it's like on 2 sides of it, they got their own curve. So that only happen when x is in the denominator. Otherwise, right, all the graphs are connected actually. Okay, so I think this is the one that most people will get thrown off. First of all, you find your graph looks so weird. Okay. And then if you get past that, getting the straight line is not the issue. Okay. Getting a straight line is not an issue. Just get a small table. Okay, it's up to you. You can also be choosing table like -303. Just make sure your straight line is long enough to cut across the whole curve. Okay, and then getting the intersection is also not very difficult. Okay, you just have to read the intersection and make sure you put your dotted line to indicate the intersection. Okay, this one, the next part is a very typical one. Okay, but for some of you, sometimes you keep forgetting how to do this. So these values that they are mentioning, right, is these 2 values. So these 2 values are the solution to a cubic equation. So a lot of people will be like, then how do I do it? Okay. So if you want the equation, you got to apply simultaneous equation. So you got to do this is an intersection. So it's something like this is equation 1, this is equation 2. Do the simultaneous. Try to make the simultaneous look like a cubic equation eventually. So it comes from the intersection of the line and the curve. So you try to do the simultaneous. How do you do the simultaneous? Y is equal to this. y is equal to this. So both of them are y. So both of them are supposed to be equal. So that is the first step. After this, right, you actually need to make it look like an x cube. It looks very complicated. Okay, so how am I going to make it look like an x cube? First of all, there is an x squared at the bottom. So we are going to multiply x squared on both sides. I'm going to multiply x squared on both sides. So, okay, maybe I will do it here so that you can see how I multiply the x squared. So when I multiply x squared on both sides, so you can do your individual expansion. When you do the individual expansion, you find that the x cube starts to appear. You do the individual expansion, you will find the x cube starts to appear. Okay, and then when the x cube starts to appear, you can gather all of them to one side. So what I did was I gathered the 3x cube and this to the left side. That's how I get the half x cube. Then after the half x cube, I also gather the x cube together. So I gather everything to the left side and I'm just left with a number. So after I'm just left with the number like this, because you remember your objective is to get the x cube. So you multiply by 2. You multiply by 2 on both sides. So you multiply by 2 on both sides. So when you multiply by 2 and you slowly multiply in, you realize that you got a nice x cube. And that's where you can compare with the equation. As you compare with the equation, you get your A, you get your B. So the solutions to the equation comes from the simultaneous. You do not need to put the answer back. So some of you end up getting your answer here. You return it back to the equation or something. Then you find like the whole thing get very messy. No need. Your job is to understand that the solution comes from intersection. And intersection leads you to the idea of simultaneous. That's why we need to do simultaneous between the line and the curve. And the simultaneous is such that it will lead you to the format of the equation that we want. It's a very important thing and it always appears for O-level for graphical solution. The concept of simultaneous. Okay, so this one is very important and I think there will be a lot of people who find this question difficult because of the graph difficulty that you encounter.